Welcome back. This is part 2 of Latitude, Longitude. Now you've had a chance to get your feet wet a little bit with just the coordinate system. Now we're going to use that coordinate system to talk about time zones and how time zones change depending on what direction you go on the planet. So here we have talked about a few quick shortcuts to figure out which way we're going and what do we do with time. So we measure time zones based on our rate of rotation, hour, meaning Earths, of 15 degrees per 1 hour. For those that are in California, they're not to 1 p.m. yet. So they're still in the morning, meaning they have not rotated to where we are relative to the sun. So eventually the sun in their sky will rotate to where ours is now, but that will take 3 hours because their time zone is roughly 45 degrees of longitude difference. So if they're 45 degrees of longitude difference, divide that by 15 degrees per hour and you get 3 hours. That's the quick and dirty version. Let's be a little more specific looking at this map and discussing just a little further that when we're also going east, we're adding time. Here's the prime meridian right down the center. East of the prime meridian is the eastern hemisphere. West is the western hemisphere. Now, in each hemisphere, you can travel east and west. So if I'm in the western hemisphere, I can start here and go more west in the western hemisphere. I could also be here in the western hemisphere and travel in the east direction in this hemisphere. So with that, if I'm going to the west, I'm going to subtract time in the western hemisphere. And if I'm going to the east in the western hemisphere, I'm going to add time. Same thing happens in the eastern hemisphere. I could start over here and travel west in this half of the earth. Or I could travel eastward in this half of the earth. And that will impact time zones the same. The only thing we'll talk about as an exception is if you hop over the prime meridian. That has a little funny calculation which I'll share later. Alright, let's go here and go through 2 of them together with our setup. So the setup is telling us first we have to determine whether we're going east or we're going west. We're going to then count the total number of degrees that you've moved with longitude and then divide by that 15 degrees per hour rate of rotation. Then you will eventually add or subtract according to what direction you're going. West being subtraction, east being addition. So let's take a look here. If it's 8 a.m. at 100 degrees west longitude, what time is it at 145 degrees west longitude? So we start here at 100 degrees west. We ask ourselves, did we go more west or less west where we ended up? Well, we started at 100, we got bigger, so we went more west. So we're going west. Which means, as a reminder to yourself, you're going to subtract at the end. How many total degrees? Well, we have to find the difference. The difference between them is 45 degrees of longitude. We're going to divide that by the rate of rotation, 15. So 45 divided by 15, we get, well, divided by 15 degrees per hour, we get 3 hours. Well, we're getting a difference of 3 hours. We're subtracting it from the original time. So we end up with 5 a.m. Let's come down here. If it's 5:37 a.m. at 90 degrees west longitude, what time is it at 15 degrees longitude? Okay, so we start at 90 degrees west and we ended up at 15. Did we go more west or less west in the western hemisphere? We went from 90 to 15. We went less west, meaning we traveled east in direction, but we were in the western hemisphere. So we put east, which means we are going to add the time for our final location. How many total degrees? Subtract the 2, you get 75 degrees of longitude. Divide that by 15 degrees per hour, and you get 5 hours. Well, Our original time was 5:37 a.m. We're adding the time because we're traveling east for this example, and we add 5 hours. So at our final destination, 10:37 a.m. Now, with that said, if you end up, ignore this for now, that's for lab, if you end up going over the prime meridian, okay, so if you go over the prime meridian, you're actually going to add your differences of your longitudes rather than subtracting the beginning and the end one. So if we started at 15 degrees west and we ended up at 30 degrees east, well, it's obvious that we're going east, we're adding, but we have to determine the total amount of degrees in between. So if we're starting at 15 degrees west and we cross 0, think of it like a number line. There's an amount on this side and there's an amount on this side. You have to add them together for the total gap in between. So in this case, instead of it just being 15 degrees, you're not subtracting these two, you're adding each gap. So you get a total of 45 degrees in between going east. So that's a trick there. So what I'd like you to do is I'd like you to pause the video, work on these other 3, and we'll pick up and check in with each other. Okay, so you're back from pausing the video and doing these ones and trying it out. So here are our answers. Let's check in with them. If you have questions about them, flag me in the room or see me the next day or see me whenever you're going to see me or send me a message so that we can check in together about these. Okay, now let's move on to the guided practice questions. But instead of going to the guided practice questions that are labeled guided practice, I would prefer instead to go to the independent practice and work on question 1 and 2, which is page 65 of the packet, the Earth Science Notes packet. So pause it up, give these a shot, good luck, we'll check in soon. Okay, so base your answer to the question on the map below and your knowledge of Earth science, which you've got some of now. All right, the map shows 4 time zones and some latitude and longitude lines across the continental United States. Some cities are labeled on the map. Ta-da, ta-da. Okay, so we've got longitudes. That's what's important right now. And let's just familiarize ourselves before we dive into this question. Looks like we got latitude and longitudes, and the dots for the cities are located underneath most of the names. Down here, it says, identify the motion that provides the basis for our system of local time and time zones. Well, Earth's motion, that's rotation, which it's always good to kind of throw it in there that it's 15 degrees per hour. That's the basis for all of it. Also, whenever you do questions, keep in mind which figures are which based on the questions, because sometimes they have you flip back. Number 2, the map below shows 4 major time zones in the United States. The dashed line represent meridians of longitude. Meridians are these lines. Okay? It's another vocabulary word. Earth science likes to use 75,000 synonyms for everything. So the locations of New York City and Denver are shown here. Boom. Boom. All right, now we have to figure out what time in New York City when it's noon in Denver. All right, kiddos, it's noon. Noon is a word you may not be familiar with. Noon is 12 p.m., midnight is 12 a.m. All right, so New York City. All right, so we start here, we end there. What direction are we going? We're going east. So we're going to add at the end whatever difference we're dealing with. We now need to find the difference in longitudes. 105, 75. Throw it in a calculator or simply look here. That's 15 degrees. This is another 15 degrees. So 15 plus 15 equals 30 degrees difference between the two of them. Divide by our rate of rotation. 15 degrees per hour. Boom. And we can spit out a final answer of 2 hours. But that's not what we have here. We have to figure out the actual clock time. So we have 12, we're adding 2, So we get to PM, choice 2. All right, so if you've got any other questions, feel free to make sure that you're either sending me a message in Zoom, you send me a message in Jupiter Classroom, or maybe you are live in front of me right now while I stand here and you're watching this, and then you look at me and you're like, wait, Mr. Ryan, you're talking to me, but you're here. Okay, I know, it gets confusing. It's like a conundrum, it's a quagmire. Anyways, point is, check in with me before you jump into independent practice if you need it. Make sure you do a challenge sheet, get those points, and then give me a checkpoint. Fill that out, be honest about it, and I'll see you soon.